So with the player now attached to the main camera by the game manager, we're going to use the uh, we're gonna use the camera to move it with the player when we move around. So let's open up third-person camera script. We have already assigned the local player um, to the transform, but if we want to look a little bit ahead of the player and maybe from a different perspective, or maybe not directly behind the player, we're going to use a camera target, which will be transform camera look target. And we also want to use a camera offset, which so we can change the position of our camera a little bit. So we're going to use serialized field, factor 3, camera offset. You could also do a public method to let them show in the inspector, but I don't want to have the camera offset available for any other classes who have access to the third-person camera. So that's why I use the serialized field. We're also going to use serialized field with a float for damping, so we can control the speed at which the camera moves to its position. All right. So now let's head over to Unity, take a look at the player. So if we look directly at the player from maybe behind the player, we look directly at the player. I wanted to look at like a little bit ahead. So what we're going to do, we're going to add a new game object to the player. Let's call it same camera look target. There we go. Now, when the local player joins, we're going to assign the camera look target as well. So camera look target will be player. Well, let's use the local player transform. Fine. So it will find child name, the transform by its name. Now let's check if the camera look target equals null. If it does, we're just going to assign a different camera look target to the local player transform. Maybe you forget to add this game object, so you can, well, we won't have an empty camera look target. Now in the update function method, we're actually going to move the target position. So we're going to use add the factor 3 target position, camera look target, position. Let's add the local player transform forward. Transform forward times camera offset. Okay. So what this basically does, it will set the target to the position of the camera look target, add the transforms forward of the local player, and then add the camera offset Z. So if we make a negative Z, it will move the camera back behind the player. We're also going to do it for the up and the right of the local player. So let's do local player, transform up, add camera offset Y, and also the local player transform right times camera offset X. So we can, with the last one, we can, with this one, we can adjust the height, and with this one, we can adjust the look angle to the left or to the right of the player's shoulder. So when you are crouched against the wall, we can switch the camera if you want. All right, and now we just need to move the target, the transform position to the target position. Transform position, and we will of course lerp it because we want to lag behind the player a little bit. So it's going to be lerp from the transform's current position to the target position. and then we're going to use the damping value times the time per delta. Now let's take a look at the camera. We're going to leave the offset empty. Let's see what happens. So we have the camera look target. Let's add a little bit in front of the player. Let's also add it a little bit higher. Well, we can adjust it later. Now, if we start the game and we look at the camera, did something happen? No. Maybe because the damping is, yeah, there we go. Because the damping was 0, it will stay at its position, but you saw it moving to the camera target. Now we're going to add a negative Z value to move the camera back. Just move the camera back from the camera look target. There we go. We're also going to add it a little bit higher. Maybe like, oh, this is maybe too much, but we can adjust it. So if we move it to the side or to the other side. So this way we can control the position of the camera based on the player's location and also the damping. So if I move forward right now, you can see the camera moving with the player at a slow rate. Now, right now it's too slow because I'm losing sight of the player. So I'm gonna increase the damping value so the camera will be faster to its position. And now you can see that it works much better. Let's copy these values and then paste those values. Let's change it a little bit, -7 I think. There we go. Now, so now we follow the player, but we also want to rotate the camera with the player. So let's move the player. Let's go to the player. Open up the player class, and now we want to control the way the player rotates with the mouse. So we're moving here in the update function, in the update method, based on the keyboard input. And now we're going to use the mouse input. Like I said 2 videos back, the mouse input is raw. So if you directly assign the variables to the to control the camera movement, it will be very jerky and direct. So we want to use damping and sensitivity for it. So we're going to need a factor 2 to hold variables of the previous frame. So it's going to be a mouse input factor 2. Then we're going to assign it in the update. Mouse input .x will be, well, we could do like the player input mouse input .x, which will work, but we're going to lerp it. So we're going to use methaf lerp, and we're going to lerp from the current mouse input .x to the new player input .x mouse input .x, and then we're going to divide it by the mouse control on the X. So we have damping for X and Y. There's also we won't do the Y-axis yet. Just going to use the transform rotate, and we're going to rotate around the world vector up, because we don't want to rotate it on the transforms up when we are on a slope or anything. So we're just going to use transform rotate vector 3 up, and we're going to do multiply by the mouse input .x, and we also going to assign it. We're going to multiply it by mouse control sensitivity on the x-axis. So we can control sensitivity as well, the speed at which we rotate. So now let's take a look what that does. Right now nothing happens. Did I? There's no sensitivity, so maybe I have to. There we go. So with damping at 0, there's no damping, so it's direct on what I'm doing. But if I add like a very high value of 50, you can see it will slowly lag behind the player's control input. So like a better setting, maybe 5, whatever you prefer. Let's change the camera directly behind the player for now. There we go. Maybe add, let's add a little cube to the mesh of the player, so we can see what's in front of the player, what's the front of the player. So let's raise it a little bit. Let's increase the screen. There we go. So just to have some idea of the forward of the player. Again, I forgot to assign the damping and sensitivity, so it was 5, 72. Now you can see the front of the player. What happens now is the camera isn't following the rotation of the player, so we're going to do that right away. Let's move to the third-person camera script. So just like the rotation, the position, we want to lag a little bit with the rotation. So we're going to get a rotation. We need to rotate to. So we get a target rotation, which will be the quaternion look rotation, which basically takes the camera look target, and we subtract the target position, which will be the direction of which we want to look, around the factor 3 up. Now, with the target rotation, here we go, we're gonna transform rotate, quaternion lerp, the current rotation, rotation, target rotation, and for now just use the same damping. Let's see what happens now. Wait. Oh, target rotation. Now I'm missing something else. Target rotation, factor 3. Target position, camera look. Oh, that should be camera look target. It's a transform, so we need to get the position. So we subtract the position of both of the camera look target and the current target position. Then we have the direction of the way we want to look. Yeah, it compiles the way we want. Now just set damping to 5, sensitivity to 2, and see what happens. There we go. So now, if you take a look at the scene view as well, you can see the camera lagging behind the player, but perfectly following it, keeping it in view as well. If it goes out of your view, just adjust, create a higher damping. So if my damping is low, my player gets really close to the camera and outside when I'm moving to the side. So by increasing the damping or moving the camera further down, you get the player still inside. Right, that's it for now. See you in the next movie.